prove A subset B if and only if A intersect B is A. So let's go with the first direction first. Prove A subset of B leads to A intersect B equal A. Okay. So if A is a subset of B, that means for all X that's in A, also X will be in B, because that's what it means to be a subset. It means all the elements that are in A are also in B. And it's possible that B would have some elements in it that are not in A. So let's calculate now the intersection. That'd be all X, where X is in A and X is in B. But X being in A implies X also is in B. And if X is in B and X is not in A, then we don't have the and. So basically, in summary, in short, it means the X being in B is redundant, because X is in A, well, automatically means it's in B. And if there was an X that was in B and not in A, then we wouldn't have the and anyways. So we're just left with this X is in A, or in other words, A. So i.e., we have A intersect B is equal to A, and that comes from A being a subset of B. Now, let's see if we can prove the other direction. So prove now that A intersect B equals A. That leads to A being a subset of B. Okay. I mean, I guess it's kind of similar logic, really. I wonder if we could do it in some other kind of fancier way. Um, uh, or do I kind of have to do it the same way? I mean, I could just do it basically the same way, but that doesn't seem interesting. But what you're saying is that X is in A and X is in B. That's the same set as X, where X is in A. So that means, i.e., X in A and X in B is equivalent to X being just in A. So logically, therefore, X in B must follow from X being in A. And the only way that can be the case is that if that can only be the case all of x in A is also an x in B, i.e. The subset, because this means if x is in A, that follows then that x is in B. So we have now the result that A is a subset of B from A intersecting B being equal to A. I guess this is an okay proof.